Hello, this is section 8.4, Operations with Radical Expressions. Part 1, Adding and Subtracting Radical Expressions. If they have the same index and the same radicand, these radical expressions are called like terms. We can simplify expressions involving radicals by combining like terms. Simplify each expression. Part 1, number 1, I mean. Square root of 7 plus 5 square root of 7 minus 2 square root of 7. The thing we have to remember here is that there's a 1 in front of here. So we get 1 plus 5 minus 2, which is 4 square root of 7. 6 square root of x minus cube root of 4 minus 5 square root of x plus 2 cubed root of 4. So here not everything is like terms like in the last one, but these two are like terms. 6 minus 5 is 1 square root of x. And then we get negative cubed root of 4 plus 2 cubed root of 4, which is 1 cubed root of 4. So our final answer is square root of x plus cubed root of 4. Number 3, 3 fifth root of x squared y cubed minus fifth root of x squared y cubed. These are like terms. 3 minus that 1 gives us 2 fifth root of x squared y cubed. Number 4, cubed root of 54y to the fifth plus 4 cubed root of 2y squared. At first glance, this may not seem like they're like terms, but remember we can simplify radicals. So 54, I'm going to do a factor tree. And then y to the fifth is the same thing as y cubed times y squared. So it becomes the cube root of 3 cubed times 2 times y cubed times y squared plus 4 cube root of 2y squared. This then becomes 3y cubed root of 2y squared plus 4 cubed root of 2y squared. So now they are like terms, at least with the radicals. So I need to go 3y plus 4, but 3y and 4 are not like terms, so it just stays 3y plus 4 in parentheses cubed root of 2y squared. Number 5, square root of 20 plus 3 square root of 5. Well, 20 is 5 and 4, which is then 2 and 2. So this becomes the square root of 2 squared times 5 plus 3 square root of 5, which is 2 square root of 5 plus 3 square root of 5, and 2 plus 3 is 5 square root of 5. Number 6, we have 1/2 fourth root of 48 minus 2/3 fourth root of 243. So I'm going to do a factor tree for 48 and 243. So 48 becomes the fourth root of 2 to the fourth times 3, and then 243 becomes the fourth root of 3 to the fourth times 3. So this is 1/2 times 2 fourth root of 3 minus 2/3 times 3 fourth root of 3. The 1/2 and 2 cancels out, so we get fourth root of 3. The 3's cancel out, so minus 2 fourth root of 3. Now they're like terms. 1 minus 2 is negative 1 fourth root of 3. Number 7, 9 square root of 50m squared minus 6 square root of 48m squared. So I'm going to do a factor tree for 50. And then I already have a factor tree for 48 up by number 6. So this becomes 9 times the square root of 5 squared times 2 minus 6 times the square root of 2 squared times 2 squared times 3m squared. So this becomes 9 times 5 square root of 2 minus 6 times 2 times 2 times the absolute value of m square root of 3, which gives us 45 square root of 2 minus 24 absolute value of m square root of 3. This time the radicals are not like terms, so I cannot combine any further. And remember, on my open math, if it says assume the variables are positive or non-negative, you do not need to put the absolute value signs. Number 8, the square root of 27p cubed minus the square root of 48p cubed. So the first thing we're going to do is do a factor tree for 27. And then I do not need to do a factor tree for 48 because I already did it in number 6. So this becomes the square root of 3 squared times 3, and then p squared times p minus the square root of 2 squared times 2 squared times 3 times p squared times p. So we get 3 absolute value of p square root of 3p minus 2 times 2 absolute value of p times square root of 3p, which is 3 absolute value of p square root of 3p minus 4 absolute value of p square root of 3p. Now everything's like terms. 3 minus 4 is negative. Absolute value of p square root of 3p. Multiplying radical expressions. When multiplying radicals, we use the product rule. The nth root of a times the nth root of b is the nth root of a times b. When we multiply two radicals, they must have the same index. Simplify each expression. Square root of 6 times square root of 3, well, that's square root of 18. And then I notice 18 is the same thing as 9 times 2. And then the square root of 9 is 3, square root of 2. Now here, I'm going to use the commutative property of multiplication just to flip-flop these. So it becomes 3 times 3 times the square root of 3 times the square root of 6. So we get 9 times the square root of 18. The square root of 18 we already know is 3 square root of 2. And then 9 times 3 is 27 square root of 2. Part C. 2 fourth root of 20 y squared times 3 fourth root of 28 y cubed. I need factor trees for 20 and 28. 20. There we go. So this becomes 2 fourth root of 2 squared times 5y squared times 3 fourth root of 2 squared times 7y cubed. Can't simplify anything, so I am going to just multiply across now. So 2 times 3 is 6. Fourth root. 2 squared times 2 squared is 2 to the fourth. 5 times 7 is 35. Y squared times y cubed is y to the fifth. And then this becomes 6 times 2, fourth root of 35. But now that y to the fifth, I can split up into y to the fourth times y. So then this becomes 12, absolute value of y, fourth root of 35y. Part D, because of the parentheses, we need to distribute. Square root of 3 times 2 is 2, square root of 3. Square root of 3 times 5 is square root of 15. Neither of those can be simplified. They're not like terms, so they cannot be combined. So we are done. Part E. Square root of 6 times square root of 12 is the square root of 72. Square root of 6 times square root of 3 is square root of 18. Square root of 18 we already know is 3 square root of 2 from above, but for 72 I need to do a factor tree. So that becomes square root of 2 squared times 3 squared times 2. So that becomes 2 times 3 square root of 2 minus 3 square root of 2. 2 times 3 is 6, minus 3 is 3 square root of 2. Now, don't forget, when you have two sets of parentheses, you have to multiply everything in the first set of parentheses by everything in the second set of parentheses. So 2 square root of 7 times square root of 7 is 2 square root of 49. 2 square root of 7 times 1 is 2 square root of 7. Negative 4 times square root of 7 is negative 4 square root of 7. And negative 4 times 1 is negative 4. So we get 2 times 7. These are like terms, so minus 2 square root of 7 minus 4. And we get 14 minus 2 square root of 7 minus 4. And then the 14 and 4 are like terms, so we get 10 minus 2 square root of 7. Do not make the mistake, this is not equal to 8 square root of 7. Because the 10 and the 2 square root of 7 are not like terms, we cannot combine them. A lot of people see the 10 minus 2 and they want to go 8. You cannot do that. Part G. 5 square root of 3 times square root of 2 is 5 square root of 6. 5 square root of 3 times 4 square root of 5 is 20 square root of 15. Negative square root of 7 times square root of 2 is negative square root of 14. And negative square root of 7 times 4 square root of 5 is negative 4 square root of 35. None of these terms are going to be like terms, so that is our final answer. And finally, part H, 9 minus 2 square root of 10, all squared. Do not distribute the exponent. Remember, you cannot distribute exponents over addition or subtraction, and here we have subtraction. Instead, rewrite it as 9 minus 2 square root of 10 times 9 minus 2 square root of 10. So 9 times 9 is 81. 9 times 2 square root of 10 is negative 18 square root of 10. Negative 2 square root of 10 times 9 is negative 18 square root of 10. And negative 2 square root of 10 times negative 2 square root of 10 is plus 4 square root of 100. So this becomes 81 minus 36 square root of 10 plus 4 times 10, which is 81 minus 36 square root of 10 plus 40, which is 121 minus 36 square root of 10. And that is it for section 8.4.